Hi, my name is Cameron Blake, and this is my bathroom stall lock solution. Many stall locks in public restrooms, including those at Hopewell High School, do not work, which leaves certain stalls unusable. Students at Hopewell and women in general need a way to hold the bathroom stall door shut while using the bathroom when the locks do not work. As you can see here, many of the existing stall locks do not function due to alignment issues or damaged pieces of the lock. When planning how to solve this issue, I knew I needed a solution that is user-friendly, could be stationary or transportable, and would work with various locks found in public restrooms. I began my brainstorming process with general functionality ideas and sketches, which led me to make 4 prototypes of my lock. I tested each prototype in our school bathrooms and improved each one by making the next iteration more versatile. My final solution works with all 3 Hopewell lock types based on its orientation by interacting with the existing lock and acting as a door jamb. It has 2 holes for chain attachment hookups. In the continued design of my lock, I would engrave the instructions on the side of the lock to help guide customers' uses and ensure the product is understood and used effectively. Thank you.
Hello, we worked on the Hopewell chessboard. We used the prize money won by Hopewell Engineering Stadium Design from a contest back in 2021 to buy a RiverPoint scanner, which was an important tool in our project. We hope to capture this year's faculty in an exciting and visually appealing way to appreciate our teachers' continued excellence.
First, we sent out a Google form to determine what teachers would be represented on the board. Then we contacted teachers and began scanning. Afterwards, we transferred the mesh file to Fusion 360 to reduce, cut, and repair. Creating the base in Fusion, we attached the finished head to the base. We then printed these pieces and started working on the board.
For the board, we modeled the squares in CAD and 3D printed them. We poured a thin layer of epoxy and then let the squares dry in place. We poured the rest of the epoxy over the squares after they dried to prevent them from floating, as done in our original attempt.
With more time, we would like to tidy up our pieces by spray painting them and adding teachers' names to the base using a Cricut. We would also like to make another board with little to no bubbles in the epoxy. Through this process, we learned effective communication, organization, and scheduling skills through our work with teachers. In addition, we learned how to work with mesh files in Fusion 360 for the pieces and how to work with epoxy for the board. Here's our finished board.
Hello, my name is Natalie Morales.
And I'm Thomas Shingleton.
Due to the looming climate crisis and pollution crisis, consumers all over the world are looking for a sustainable and durable option for clothing.
So, we decided to tackle this through environmentally friendly textiles, a 3D printed no waste solution. So starting off with the project, we researched different ways to make 3D printed clothing, as well as the types of filament for a 3D printer and figuring out which one we needed, which was 95A TPU filament.
We brainstormed our ideas on paper and we designed our garment in Fusion 360. After that, we determined the cure slicer settings and how we need to print the piece.
While determining those settings, we have what we considered some failed pieces. However, we did use these to figure out the capabilities of our TPU filament to be sewn together.
We ultimately adjusted the printer to print non-woven fabric that is most similar to a woven fabric. From there, it was a relatively straightforward process where all we had to do was print the pieces and sew them together.
From this project, we learned how to apply lean manufacturing to create a no-waste clothing garment, as well as gaining insight on how to configure a 3D printer and the different types of filament used.
We believe that 3D printed fabric has potential and has a place in the textile manufacturing industry as a sustainable option for consumers who value sustainability in clothing. Thank you.
Hello, my name is Eric, and this is John, and this is our filament storage container. Our problem was Hopewell engineers have no effective way to keep PLA dry or stored in an organized manner. Hopewell has 11 printers and over 30 rolls of filament of varying material, and tons of student and teacher demands for printing.
Hello, I'm John Kish, and I'll be discussing our design process. As you can see on the bottom left, we first looked toward designs for inspiration. From there, we designed and dimensioned our own box using on-shape and 3D printed parts to build our box. During this, we encountered many difficulties with the sealing of our box. In order to overcome this, we built offset hinges and laid foam, which was tested multiple times. Here is our final design with clips and hinges to keep an airtight seal with the filament, as seen on the left, and with our silica gel on the right. In the future, we would like to improve the adhesion between the parts with hot glue. We also learned a lot about additive manufacturing and the importance of documenting work. Thank you.
Hello, my name is Daniel Ando, and this is my project, the garden hose adapter. So, the problem was that at my church, people were having to bend down at the garden hose faucet in order to wash their hands outside. I designed this simple yet effective solution to 3D print a attachment that will lift the water source up so that people won't have to bend down anymore. I created all my designs in Onshape. Using the CAD software, I created a attachment and a spigot for the water to go through. With more time, I would have printed out my designs and put them to use immediately. Here's some images of the work that I have done and the past iterations that I have gone through. And here is the final product.
Hi, my name is Rachel Heggie. I'm going to be walking you through the process of constructing a growing flower pot for my chiropractor. Plant owners need a pot to house a plant for the life of the plant. My flower pot design is a compact, long-lasting solution that contains the plant as it grows. Using pre-existing solutions as a guide, I created a telescoping friction lock system using slope to find the desirable dimensions at intersection points. Modeled and 3D printed using Fusion 360, a compact and one-size-fits-all pot was born. Because of the tolerance necessary for locking, soil was able to get in between the cracks. Printing a ring using flexible TPU filament to fill this crack can ensure a leak-proof finished product. I learned that using mathematical models such as slope can reduce the time spent in trial and error. In addition, a friction locking system is not very sturdy with heavier and denser prints. Here's my final product.
Hello, my name is Kevin Morris from Hopewell High School. I noticed that Hopewell's 900 building needs a solution for privacy and safety on the windows in the building. During my time at Hopewell, I have felt that the 900 building, being as isolated and exposed as it is, deserves to have new safety factors involved. I first looked up many solutions that had to do with windows and security and privacy. I was able to come to the conclusion of frosted window film, as you see in the bottom right, as it keeps the sunlight aspect of the window and still provides safety and privacy from external danger. With this project, I learned all about how a project does not go as planned. I ran into issues with fire code and safety, and even got to the point where my solution would have to take a huge gain in budget, seeing as I also had to work with the entire building. Overall, my project was a look into real life experience, as I was faced with obstacles that outweighed the constraints that I need to provide. Things like budget and legal actions that would hold me from pursuing my project. Moving forward, I can see a potential fundraiser or sponsor that would help by being involved in the project that would help this idea finally get off the ground.
My name's Hayden, this is Matt and EJ. We are part of the Hopewell engineering team.
Here at Hopewell, we have a problem with our hall pass system. Basically, we have to get escorts to the bathroom now because people just, I guess, go off and run away in terms of not going to class.
And so our solution for that problem is to create a hall pass system. So we created a hall pass system that's color coded by each section of the school, because we go by sections of the school. And it has a good, unique design that teachers and staff can spot and see where students are supposed to be at any time, anywhere.
The next step of our solution is, once we get the HDPE sheets in, is to put them into our laser cutter that we have over here. Once we have a hole drilled in the wall for ventilation, and we cut out hall by hall and slowly produce for the whole entire school building.
Our final step is to hopefully have a good hall pass system implemented here at Hopewell High School that gets spread throughout the CMS.
Hello, my name is Ryan Nichols, and on the team are Jairo Vasquez and Andrew Waddell. Our product is a batter's box template. Coach McGeorge, the baseball team's head coach, needs an improved way to paint the batter's box.
We began accomplishing this by brainstorming and researching ideas and dimensions. We then took those ideas and dimensions and made a design in CAD. We wanted to use aluminum for our design, but unfortunately did not get funding and had to change our design around and use wood. Once we had our wood design, we began building our batter's box template. Here is what our final design looked like.
If we had more time, we would have made tracks in the wood, made a slider piece for the spray can that slides through those tracks, and made the frame more sturdy.
Throughout our project, we learned how to use many tools such as a miter saw, a table saw, a drill press, and many other power tools. Another thing we learned is how to straighten wood 2x4s with cinder blocks, as seen in the photo below.
My name is James Karowski, and I'm here to present today Hopewell's 3D Print Store. For context, the current Hopewell principal needs a fundraiser to improve the school. Originally, the idea for the store was that I would only sell custom designs, also known as commissions. Eventually, I added pre-designed products to the store. In the end, the store has 24 pre-designed products while still maintaining its custom design roots. During this process, I learned how to create a store and improved my CAD skills. The next thing I'll do for this project is to improve it as much as I can. Thank you.
Hello, my name is Ryan Nichols, and in my group are Jairo Vasquez and Andrew Waddell. Our project is Media Center outlet covers. Mr. Brookshire, our school librarian, said that outlet covers are needed in the Media Center to prevent potential harm caused by student usage.
To ensure the longevity of the tables, we made outlet covers. We began making these by getting measurements of the outlets, and then with those measurements, we made sketches of possible prototypes. We then made those prototypes into CAD and 3D printed all 3 designs that we each individually made. Then we chose the best out of those 3, and then began finalizing mistakes on the design, and began to mass print them. Here's pictures of our final design. One is with the sliders open, and one is with it closed.
If we had more time, we would have printed more protectors that have all the outlets protected, made the tolerances a little smaller, and put more Hopewell logos into our design for school spirit.
Through our project, we learned many aspects of 3D printing, such as how to fix under extrusion, slicing, troubleshooting a 3D printer, and taking off and adding filament into the 3D printer.
Hello everyone, my name is Edward Johnson, and I am a student athlete at Hopewell High School, and I'm doing a project on mental health.
Problem statement. Hopewell needs a way to educate and inform athletes and students about the mental health crisis. So throughout this process, I have been gathering research and information on this topic to be a solution to my problem statement, which is doing a video that gives more information on the mental health crisis. Here are some pics from the CO2 car race, where I presented my presentation and research that I gathered to younger students to tell them about the mental health crisis. In conclusion of this project, I think throughout this process, students can learn and gain lots of valuable information and resources on mental health, and also learning new ways and techniques on how to spot mental health as well, and to become more aware of the mental health.
Hi, my name is Kayla Pham, and I noticed a problem within my neighborhood in my own yard, that there is a lack of bees in the area, thus affecting the plants and vegetation here. How visually unappealing is that? Therefore, I created a solution to attract more pollinators to the area, specifically bees. I made a mason jar beehive for mason bees, a type of bee that can't make their own hives but are excellent pollinators. The goal of this project was sustainability. So, I first cut up recycled plastic water bottles and rolled them up using a marker. Then, I put those rolled up pieces into a mason jar and wrapped some extra rope around the jar, securing it with tiny amounts of hot glue. Further testing still needs to be done though. I need to test and observe the best ways to attract mason bees to the jar so that they will pollinate my neighborhood and make the area more attractive.
Hi, I'm Cameron Blake.
I'm John Kish.
And this is the printer attachment solution. For an entire semester, the Hopewell Engineering Department had numerous rolls of PLA that were unavailable to student use. Our printer attachment solves this problem by making these rolls of filament compatible with our current printers.
So during our generating concepts, we came up with 3 designs, with us finally selecting the telescopic model. From here, we then measured the different parts of the printer, and then we designed our telescopic attachment to fit said printer, and so that it would slide through the print holder and create its own separate attachment. As you can see here in these final images, we created 3 prototypes, tested them, and then printed 11 total models, which were then installed on these printers.
In the continued design of our solution, we would create a 3-dimensional piece to hold our printer attachment onto the printers. Thank you.
Hello, I'm Thomas Shingleton.
Hello, I'm Natalie Morales.
Hello, I'm Joseph Dahl. The problem was that Hopewell wanted to cut costs from prom and homecoming while still providing a 360-degree photo booth.
And then so in order to do this, we wanted to create a design for using Vex robotics and coding in order to create a 360-degree photo booth like project in order to use the user's phone and a ring light to capture video.
Prior to designing, we researched different methods on how to create a 360 camera, including previous designs, previous patents, and DIY 360 photo booths. There were 4+ iterations to track, and all of these iterations were based on how much time it would take to print, how large the printing bed was, and how much filament was used.
There were over 7 iterations of the robot, and the changes were necessary due to instability in the previous designs of the robot, and also due to changes in the size of the track and the limited amount of resources.
There were over 4 iterations of coding. There were multiple syntax errors along with the need to determine a directional movement and implementing a start and emergency stop button. Fixing the coding to a time-based system took the majority of the time. Due to the incomplete track, it falls off at the end. And for our next step, we continue to build the track and adjust the robot as needed. During the project, we had many unexpected roadblocks that made it difficult to follow the initial schedule.
My name is Kevin Morris from Hopewell High School. I noticed that Hopewell's soccer program needs an affordable training product that will help the team with free kicks and dribbling practice. So in order to help, I tried to help provide a solution, a soccer training dummy, that will work with the program's budgets and needs. I first researched current, more expensive solutions to help form ideas that have already been used. For my design, I decided to combine the two factors that I saw most in each project, which was a strong outline and a mesh center to cushion some of the force of the ball. As I continued in development, I was able to create a CAD design that would support the materials that I was using and meet the criteria of the project. When I went to construct my product, I realized that I wouldn't have as much leeway on the torso of the dummy, seeing as the material added more constriction than I had to revise my solution in person. The base was the hardest part and took a lot of patience as it had to have most strength and be anchored well. Throughout the whole process, I learned about the precision of CAD and the restrictions that are also set by the material that are added to the constraints set by the client or the project already. Moving forward, we can start to build more products if needed and integrate them into everyday practice for the whole program.
Hey, my name is Paige Reed and this is the Lunch Tin. To begin this project, I began collecting a set of problems to solve around the school. The problem I found most interesting was the outside lunch area. Hopewell's outside lunch area is filthy. The tables are written on and the site needs to look appealing to the eye. The lack of attractiveness makes students want to avoid the space. Students find it dull and prison-like. Through a design brief, I thought about how I could improve the outside lunch area. To eliminate stains or dirt, the concrete and lunch tables will be pressure washed. The railings and poles will be painted blue to match the tables, and a mural on the brick wall outside will bring colorful elements into the area. To make the outside lunch space accessible, the cafeteria doors to the lunch tin will remain unlocked until the lunch periods are over. Adding collapsible umbrellas to the space provides shade if needed. By doing all these tasks, the lunch tin can turn from this to this. To tackle the task, I have requested volunteers from clubs like Beta, the National Honor Society, and student government. Hopewell High School will have an improved space to enjoy lunch. The space will be attractive, encouraging students to eat outside. When warmer weather occurs, students can provide shade by opening the umbrella at their table.
This is me, Matthew Patterson. A big problem we face at Hopewell in our engineering program is we don't have access to the materials that we need. Like, this is our ATV project, we barely got done because we didn't have access. There's just materials laying around. So I decided to take a change. So this is the inventory that I took to build materials or just get the materials for the project. A lot of decisions were made, but the ultimate decision was the cart system. Here, there's a board that was measured and routed for the cart, a French cleat system that was put in for the materials and the battery pack. And here is the pegboard for the wires, the VEX V5 wires that were needed to put for like resources, the ones that we don't have access to. This is where they go. This is the final product, the cart system with everything equipped that's needed. The next step is to have another cart and more multiple carts around for the engineering program. So all the resources they don't have access to will always be of access.
Hi, my name is Matthew Coco, and this right here is a video of recycled filament. When using 3D printers, you can come across a lot of wasted filament, which is a no-go. So I did some research and try to find ways to make up for that wasted filament by seeing if you can recycle it or even possibly make it. I saw that you can use PET water bottles or recycled water bottles to make this filament. All you have to do is cut it up into a thin, long line as shown, put it through the guide. As it's going through the guide, it goes into the extruder. As is in this extruder, it then melts, comes out the nose, the same diameter as filament. It then gets cooled down by the fans, and as it's being cooled down, it is getting pulled, raveled up, and spooled into the gear system. What I learned is that time management organization is a very important key factor when it's coming to projects, as well as different coding and as well as mechanical designs.
My name is Hayden Champree, and I'm hoping to bring a Hopewell disc golf course to the Hopewell campus. Using my prior experience from courses such as Bailey and Robbins Park, I was able to create my original design that you see on the left with Google Earth, and then my design on the right after walking the campus and seeing the limitations and restrictions from other sports and athletics. Knowing I needed help, I reached out to the Charlotte Disc Golf Club and special help from Mark Hulther, who helped me walk the campus and make a final design, and our athletic director, Coach Burke, to make sure that it didn't interact with any Hopewell athletics and the JROTC program. The final design that you see here was made with the help from Mark Hulther after walking the campus. 9-hole course, and is very easy for any student, gym class, or anybody that's wanting to play disc golf at the campus. Our next steps are to contact 811 before we start construction and to gather funding for the course. Throughout this process, I learned how hard it can be to get a project done with as many stakeholders as there were, especially in a government-funded program, as well as the time management that you need, as well as the patience. I hope that this project will be able to bring a course to Hopewell and can create a community and club for students that are wanting to play.